Okay, so let's say you have two functions. We have f of x and g of x, and then you're going to drop a board. It's going to fall down, and it's going to land right here, and it's only going to touch each hill once. Okay, so the question is, where are the 2 points that it touches, and what's the slope, so we can find the equation of this line. All right, so let's do some labeling here. The point where it touches f of x is going to be a comma b. The point where it touches g of x is going to be c comma d. Okay, great. So one thing you'll notice is that obviously this is a line, which means that it has the same slope everywhere, whereas the parabolas don't have the same slope everywhere. And because these things are tangent to the line, the tangent slope of the parabola at this point and at this point are going to be equal to each other. Okay, great. So we can rewrite g of x as negative x squared plus 8x minus 12. And then we take the derivative of both of these functions, obviously very important because this is a calculus problem. We have this. Okay, now f of a is going to be equal to b, and g of c is going to be equal to d, just because that's what it means to have the points a and b on f of x and c comma d in g of x. Now the slope, as I said before, is going to be equal to the tangent of the first parabola at point A, and it's also going to be equal to the tangent of the second parabola at point C. And just from the definition of the slope, it's going to be rise over run. Now this is great because we have an equation linking a and b, an equation linking c and d, equation linking a and c, and equation linking all of them. So what we're going to do is try to rewrite this equation, but we're going to substitute everything so we can get just the variable c. So first thing we do is we use this equation to find out, just plug in the definition of f of x to find 1 minus a squared equals b. We do the same thing here, plugging in the c and d to g of x to get negative c squared plus 8c minus 12 is equal to d. Then we plug in a and c to get negative 2a is equal to negative 2c plus 8. And then that can be rewritten as c is equal to a plus 4, and a is equal to c minus 4, and c minus a is equal to 4. This one is immediately useful because you can see we have a c minus a over here. So we're going to write m is equal to d minus b over c minus a, which can be substituted with 4, and then you multiply 4 by both sides. Great. Now we're going to substitute d for this equation to get it in c's. So that's going to be negative c squared plus 8c minus 12. And then we can have minus b, but we're going to first substitute b for this equation to get a's. So that's 1 minus a squared. And then we're going to use this equation to get it in c's. So what we have is c minus 4 squared. This works out to be c squared plus 8c minus 12 minus 1 plus c squared minus 8c plus 16. And this is where the magic happens because these two cancel out and these two cancel out. So we just have 4m is equal to 3, or m is equal to 3/4. Perfect. And that's the hard part. Now we just plug in the slope to all these equations to get a, b, c, and d. So we have f prime of a is equal to 3/4. So negative 2a is equal to 3/4. So a is equal to negative 3/8. And then we plug in a to the equation 1 minus a squared is equal to b to get b is equal to 8/9. Then we do the same thing with g prime of c is equal to m, which that's going to be equal to 3/4. And then so negative 2c plus 8 is equal to 3/4. And then that works out to c is equal to 29/8. And then you plug the equation. This one is kind of painful. C squared plus 8c minus 12 is equal to D, once you plug in 29/8 in here, you get D is equal to 247/64. Great, so when you have these equations, when you have these values for A, B, C, and D, you plug that into the point slope form. You can use A and B or B and C, and you get the same line, which is perfect, and then you know what these are, and you know what the slope is. Okay, great.